Dear friends, in this video we are going to see applications of Laplace transform to solve system of differential equations. We have to solve system of differential equations by using Laplace transform. Okay. So this is question. What is system? System means more than one, means two equations or three equations. See, y is dependent variable and z is also dependent variable, but t is independent variable. So there are three variables y, z, t. T is independent because dt is there. Okay, and this y is dependent. Here z is dependent. So there are two dependent variables and one is t is independent variable. Such a two equations both combinedly called as system. Okay. So we have to solve this differential equation means what? That means we have to find out dependent variables in terms of independent. That means we have to find out y and z. Okay, let us start. So first we write system in dash form. Okay, dash notation. dy by dt means y dash is equal to minus z. dz by dt means z dash is equal to y. This is called dash notation. And now we apply basic formula. If you take Laplace on both sides, take Laplace. So we get m into bracket y dash is equal to minus L of z and L of z dash is equal to L of y. So together we can write like this. Ly dash means yes into Ly minus y of 0, and which is equal to L of z minus times. That means I have written this. Then this can be written as yes into L of z because it is Laplace of z dash minus 0 of 0, and which is equal to L of y. That is the right hand side as it is. There is no formula. Okay, but Ly dash there is formula. Lz dash there is formula. So here I will write and. Okay, so yes into Ly, then minus y 0. So here you have one initial condition 1 is equal to minus L of z, and here yes L of z. Z at 0 is 0. This is initial condition. This is L of y. And then we simplify these equations. Simplify. That means here yes into Ly as it is. This minus Lz we can shift on left and minus 1 on right because it is constant. Similarly, yes into this, but this is Ly. So we take on left, it comes minus Ly. Okay, this term becomes negative and this is already positive. So yes into L of z. So same method of writing. Below this, same terms. Okay, we have written. Now combinedly we can solve this. We have to eliminate y, Ly. So we multiply this equation by 1 and multiply this equation by yes. So what is the job? This remains as it is. But there is change. See what is going on? It's method of solving system of differential equations by using Laplace transform. Now if you add, we are getting elimination, and here we are left with this. So this can be written as L of z into bracket. There is a square, and this is plus means 1, and on right hand side 1 plus 0 is 1. Therefore, L of z is a single equation. L of z is equal to 1 divided by. Now I can shift s square plus 1. Therefore, z is equal to n inverse into bracket 1 divided by s square plus 1. So z of t is equal to inverse Laplace of this comes sin t. So this is what is to this is first. So solving system means we have to find out y is z is related. Now we have to find out y. See, this is simplest equation to find y. So that y is equal to dz by dt, and therefore y is equal to derivative of this d by dt into sin t, which is cos t. This is second. So y is equal to cos t and z is equal to sin t is the solution of the system. In the beginning, we have seen this y is dependent, z is dependent, t is independent. So solve the system means we have to find out dependent variables in terms of independent variable. So both are, you can see, in terms of t. So this is what is the solution of the simultaneous equations. This is what is the application of Laplace to solve system of differential equations.